Since its arrival on Mars in 2012, NASA's Curiosity rover has zacked and drilled ancient rocks in the hopes of finding evidence for past life. But it may never get a chance to investigate something far more exciting: the possibility that Martian microbes exist today. In the coming years, as the rover trundles up the side of Gioli's Mons, it will pass rocks that, seen from orbit, seem to host mysteriously intermittent dark streaks, perhaps marking seasonal water seeps. But NASA's Planetary Protection Office, charged with keeping earthly microbes from colonizing other bodies, has said it may make a visit. It fears that Curiosity could contaminate this so-called special region because the rover was not fully sterilized before launch. To Alberto Ferrin, the planetary scientist at Cornell University, that makes no sense. Sooner or later humans biped rovers that can't be sterilized will set foot on the planet, hopelessly confounding any hope of finding indigenous life. He and several colleagues argue in an op-ed in Press this month in the journal Astrobiology. We need to investigate Mars' special regions carefully and fully prior to human missions, he says. Bureaucratic changes at NASA could create an opening for his views, which some Curiosity team members share. In July, NASA announced, through a blunt job posting, that the Planetary Protection Office was moving out of its longtime home in the Science Directorate to NASA's Office of Safety and Mission Assurance in Washington, D.C., a place more accustomed to translating protocols into engineering practice. Cassie Conley, the Planetary Protection Office's longtime chief, will face competition to keep her job, and she could be replaced by someone with less strict views on sterilization requirements. Meanwhile, by the end of this year, the National Academies of Sciences, Engineering, and Medicine are expected to complete a head-to-toe examination of how the office works and whether it keeps abreast with current science. And later this year NASA is holding a major workshop that could lead to a redefinition of special regions on Mars, the warm and wet areas that are off-limits for all but the most sterile of spacecraft. The Viking landers of the 1970s were the only missions to Mars ever to be completely clean to the highest standards of planetary protection. They were baked in a purpose-built giant oven, and the cost of doing so is thought to have been roughly 10% of the mission. Ever since then, says Conley, researchers have complained about the office, as if it exists solely to burden them and make their missions impossibly expensive. People like to have a villain, she says. The office has clashed in recent years with the Jet Propulsion Laboratory (JPL) in Pasadena, California, which assembled Curiosity. JPL baked parts of the rover in ovens at 110 degrees C for nearly a week, to sterilize them to a level where the rover could explore special regions. But in 2011, weeks before launch, JPL engineers decided that Curiosity should launch with one of its drill bits mounted on its robotic arm. They opened the already sterilized bit box, a violation of planetary protection protocols that caused the office to downgrade Curiosity's sterility. During postmortems, JPL engineers complained about the confusing and vague way the offices presented its requirements. More recently, says John Rummel, the biologist who was NASA's planetary protection officer before Conley, JPL has butted heads with the office over the next big mission, the Mars 2020 rover, which will gather rock samples for later retrieval to Earth. JPL is interested in having the rover target areas with subsurface brines, an activity that would not be allowed with its planned level of cleanliness. Moreover, the Planetary Protection Office has not yet agreed on the efficacy of the techniques JPL will use to sterilize the tubes in which the rover will cache rock cores. If the issues aren't resolved, Rummel says, the rover could be headed for a bureaucratic train wreck. The office, which has always been limited by a small budget and staff, continues to gauge a spacecraft's bioburden based on a classic measure, the number of cultivable microbial spores it carries. Some of the numbers we've been operating on date back decades, and it'd be great to revisit them, says Sarah Johnson, the planetary scientist at Georgetown University in Washington, D.C. She thinks the office should take advantage of two innovations: chemicals that can separate DNA from dead and living cells, and genomic sequencers that can classify the living ones by type. Scientists could then, for example, assess their individual likelihoods of surviving on Mars. As a member of the Curiosity team, Johnson would like to see a change in policy that would allow the rover to sidle up to the wet streaks to give them a close look, even if the drill itself, currently on the fritz since December 2016, could not be used. In their op-ed, Farron and his colleagues go further, saying NASA should slightly lower its sterilization standards so that robots as clean as Curiosity could explore special regions. Farron says there is growing evidence that the harsh environment on the Martian surface, a combination of frigid temperatures, caused to chemicals and deadly cosmic radiation, would kill Earth microbes quickly, especially in the limited numbers that ride along with robots. Even if some survive, he adds, future missions could distinguish between earthly and Martian microbes by sequencing their genomes. Rummel, who is now at East Carolina University in Greenville, North Carolina, plans to submit a rebuttal to astrobiologists. He disagrees with Farron's assumption that contamination from robots won't spread, but that it would from human exploration. Rummel says Farron also makes technical mistakes in his paper, like insisting that the 1967 Outer Space Treaty would have to be amended to reflect the planetary protection changes he proposes it wouldn't. Whether NASA's policy might change won't be clear until a new planetary protection chief is installed, and after the National Academy's panel and Special Regents Workshop have weighed in. But some planetary scientists aren't losing too much sleep over the debate. Jim Casting, a geoscientist at Pennsylvania State University and State College, says that the soil on Mars has proved to be so lethal that the chances of finding life in the Martian near-surface environment are close to nil.